5 in Algebra 2. And for your do now today, I wanted you to try to complete the odd numbers on this worksheet, number 1 through 9, the odd numbers. The rest of it we'll talk about in a little bit here. So I'm going to put this one to the side. You guys can do the same. And I'm going to also put these sticky notes to the side. And then I'll pull out my notebook, and that is where I will work things out. So let me just title this real quick, and I'll pause it while I title it. Okay, so I have my paper titled, and I'm going to go ahead and just copy down the first problem. And for the first two of our do now, numbers 1 and 3, we're using substitution to solve these systems. So this will be more of a review than anything. Our first equation is y equals 2x plus 4. And our second equation is negative 3x minus y equals 11. So if I want to solve for x and y using substitution here, what would be a good first step? Any ideas? I know it's Monday. Who feels brave? Even if you're not sure if it's the right answer, somebody tell me, what is the first thing you did?
Plug in y.
Plug in y. Okay, so when you say plug in y, what do you mean by that?
2x plus 4.
Yes. So I see right here my first equation, I've already got y equals. Y is by itself. So I know that anything that is y equals or is the same as 2x plus 4. So my second equation has a y in it. Let's take that 2x plus 4 and substitute it for our y. So when we do that, is my door locked? It might be. Thank you, Charlie.
You will.
So what we'll do is we'll use our second equation, but instead of writing y, we're going to substitute for that 2x plus 4. So negative 3x minus, I'm not going to write y, I'll write 2x plus 4. So I have negative 3x minus 2x plus 4. What else am I missing here?
Equals 11.
Equals 11. I need to rewrite that whole equation here. So I plugged it in. What should I do next?
Put your other 1. You got equals 1.
Oh, my bad.
I was very confused.
My bad.
We'll get there.
It's not equal to 1. It's equal to 11. Thank you. Thank you for catching that. Okay, so now that I have it written down properly, what should I do from here? Distribute. So this is tricky. There's not a number to distribute. So what do I do? This is really the same thing as 1, negative 1. So we can think of this as negative 1 times each term, or we can think of this as just distributing the negative, which means anything inside of my parentheses is going to take on this negative sign. So it's going to change the sign, but not the numbers. Because if I take negative 1 times positive 2x, what do I get? Negative 2x. Okay, so I'm done with that. Now I have negative 1 times positive 4. Becomes, instead of plus 4, negative 4 minus 4. Good. Okay, now before I go to any next step, does anybody need clarification about what happened here? Make a little note. We're distributing the negative. Distribute negative. Or negative 1. You can think of it that way too. And what happens next?
Combine like term, or you bring the negative 3x down.
Yes, let's bring everything down, and then you're correct. Once we've brought everything down, we can look to see if we can combine any like terms. So I'll bring down negative 3x. I'll bring down equals. I'll bring down 11. And we like to draw a line through our equal sign to keep us organized. And then you said we should combine like terms.
Yeah.
So what like terms do we have?
Negative 3x, negative 2.
I have negative 3x and I have negative 2x. They both have x's. So what number do I get when I combine these? Negative 5x. We can think of this in two ways. We can think of it as negative 3x plus negative 2x, or we can think of it as negative 3x minus 2x. Either way, when I type this in, negative 3 minus 2, I will still get negative 5. Negative 3, get that to focus so you can see what I'm typing. Negative 3 plus negative 2. Both ways we get negative 5. So we have, combining those, we get negative 5x. Then we want to bring everything down, right? So what comes down here? What do I have to bring down? Yeah, my negative 4, my minus 4 equals 11. Good. I should just have 2 more steps and I'll have this equation solved. What is the next step?
Add 4 on both sides.
Yeah, let's add 4 on both sides. That'll cancel. 11 plus 4 is 15. And we'll bring down negative 5x equals 15. Last step.
Divide by negative 5.
Perfect. Divide by negative 5 on both sides. And we will get x equals
Negative 3.
negative 3. Good. X equals negative 3. Are we done with this problem?
No.
No. What do I need to do still?
Plug in negative 3.
Yes. Yes. So I've already plugged in y for my first step and I solved for x. Now that I have x, let's plug in x and solve for y. So I'm going to bring down my y equals equation. I have y equals 2x plus 4. When I plug in my x value, I'm going to replace the x. We won't have an x anymore because we're going to use negative 3 instead. So we'll have y equals 2 times negative 3 plus 4. And once I have that plugged in, what should I do next? Distribute or multiply. We've got 2 times negative 3, which is what?
Negative 6.
Good. Negative 6. Bring down plus 4. And what does that give us?
Negative 2.
Negative 2. Y equals negative 2. So x is negative 3, y is negative 2. What is my coordinate?
Negative 2.
Good. Negative 3 is my x. It comes first. Negative 2 is my y. So it will come second. And that is my answer. There we go. That's number 1. Using substitution. So I'll label that. This is substitution. We have any questions about number 1? Before we go to number 2, are there any major mistakes any of you made in this first problem that after seeing it worked out, you see what went wrong and it makes a little more sense now? Any learning moments happened just now?
Was first doing it because I didn't have because the Y was empty. I was doing the multiple distributing with the 3x, so I was doing decimals.
Okay, so you put in your 2x plus 4, but since there was no number, you decided to distribute that 3?
Yeah.
Okay, I see that sometimes. I see that. So that is definitely something that you might see. I'm going to write down what you did. You had the negative 3x minus, and then the 2x plus 4. Okay, equals 11. So in case you didn't catch that, what Natalia just said she did is there was no number in front of our 2x plus 4, so she thought, well, here's the closest number. Let's distribute the 3. Why can we not do that?
Did you have a minus sign in between them?
Yeah, because I've got a minus sign in between them. And plus 3, that negative 3x is a completely different term. We only want to look at what's immediately outside. Plus, there's another variable here. If it was no minus sign here, then that would be correct. But since there is a minus sign right outside of it, we're looking at that minus sign. Where we distribute the negative, just like we did here. And that turns it into negative 2x minus 4. Good, thank you for sharing. Anything else? And if not, we'll move to number 2. Let's go ahead and start on number 2. Same type of problem. We're using substitution. And I'm just going to copy. Bless you.
Thank you.
I'm going to copy down these problems. So we have 2x minus 4y equals negative 10. And then we have y equals 2x minus 2. Using the exact same method, we're still doing substitution. What should be my first step? Plug in y. So I see I have y by itself. Y equals 2x minus 2. So I want to plug this in for y in my other equation right here. So I'm going to start copying down this 2x minus 4y equals negative 10. But I'm not going to write y. What do I write instead of y?
2x minus 2.
Perfect, 2x minus 2. There's my y. Here it is again, 2x minus 2. And now that I have it plugged in, where do I go from here?
Distribute.
Distribute. What am I distributing?
Negative 4.
Good. Negative 4. Distribute into 2x and negative 4 into that negative 2. So negative 4 times 2x, what do I get?
Negative 8 again.
Good. Negative 8x. Negative 4 times negative 2. Positive 8. So it's not minus 8, it is plus 8. Those minus signs cancel each other out, becomes positive. Okay, and once we've done that, we'll bring everything down. 2x equals negative 10. I'll draw my line through the equal sign. before we move on, do we have any questions, or is there any part that we're not sure how we got? But we feel good. Okay. So what do I do next? What do I do?
Combine like that.
Combine like terms. What like terms do I have?
Negative.
Yes. 2x negative 8x. When I put them together, I get negative 6x. Good. Okay. So I'll bring everything down. I still have plus 8. I still have equals. I still have negative 10. Now what?
Subtract 8 on both sides.
Good. Subtract 8 on both sides. And we'll bring down,
Are they going to divide by negatives?
yes, negative 6x equals, what is that, negative 18?
Yeah.
Okay, perfect. And then you're right, all we gotta do is divide by negative 6 at the end.
And it's positive 3.
Perfect. We'll get x equals positive 3. Perfect. Okay, so I have x equals positive 3. How do I find my y value?
Plug in your 3 to your 2.
Yes, I'm going to plug in my x value of 3 into my y equals equation. So I have y equals, instead of 2 times x, 2 times 3 minus 2. So I plugged it in. 2 times 3 is 6. Bring down minus 2. And what do we get for y? 4. Perfect. So what is our coordinate?
3, 4.
3, 4. X comes first and then y. Nice. Very nice job, guys. So there's 2 substitution problems. We've got the answers for both. Good. Bless you.
I think we just started some math, right?
Yeah. Is there any particular spot anybody having trouble with, or feeling like they're getting stuck on anything in particular?
I was gonna ask you, like I know it's different when we're finding X and Y, but will the way to find X always be the longer equation?
In substitution, yes. Yes. When we're using this method, that's a good question. Charles asked, whenever we are solving for x and y, is the solving for x equation always going to be the longer one? With substitution, yes. Yes. The reason for that is because we're taking a whole equation and we're plugging in half of a whole equation into that. So we're kind of solving 2 big chunks at once. And we're always solving for x first. That first set of solving is going to be the longer part. Once you have x, your y will be much shorter because y is already by itself. So all you got to do is plug that in and do the 2 operations they give you. No, it's a really good question. X will always be the longer equation when we're doing substitution, for sure. So, oops, bumping stuff. Just labeled at number 2 as substitution as well. Okay. So before we go to number 3 and we look at elimination, do we have any other questions or comments, or does anybody just still need to see this, copy it down? Okay, are we ready for number 3 then? Okay. Moving on. Let's do. Okay. So number 3, now we're looking at elimination. And this is level 1 elimination. That just means that we don't have to do any multiplying. We can solve by simply adding the equations together. So I have x minus 2y equal to 19. And my second equation is negative 4x plus 2y equals negative 28. This is even. So when we are using elimination to solve a system of equations, our goal is to get one of our variables to cancel out, whether that's x or y. Anybody remember how we do that? Add them. Yes, we're just going to take the equations exactly how they are, and I'm going to treat this like one big addition problem. I can go ahead and bring down my equal sign, and we're going to add each set of terms together. Now, the way I've been teaching it is I've been going left to right, but I guess technically when we're adding by hand, we should start over here. It won't make a difference either way. But I'll start over here this time. First, I have 19 plus negative 28. So what is 19 plus negative 28?
Negative 9.
Negative 9. Okay. Negative 2y plus positive 2y.
Those kids, what?
These cancel out, equals 0. So we've eliminated our y's. Now I have x plus negative 4x.
I added a 1 in front of the x and got negative 3.
We can do that. Add a 1 in front of the x, and then you said you got negative 3x? That's correct. 1 plus negative 4 is negative 3. And there's an x. So I have negative 3x equals 9, or negative 9.
Then you divide by negative 3.
Yep, divide by negative 3.
I got a positive 3.
Perfect. And you'll get x equals positive 3. Beautiful. Okay, so I have solved for x. Once I have x solved for, or y, depending on our equations, in this case we have an x, how can I use this to find y?
Plug it into either equation.
Yes, I'm going to plug in my 3 to the x of either one of these equations. It does not matter which one you choose. Either one will work. When I'm looking at these, though, I'm thinking my top equation has smaller numbers, and so it looks a little bit easier to me. If it were me doing it, I would pick my top equation. You can still do it with the bottom one, though. But I'm going to use the top one. I'm going to just recopy that down. X minus 2y equals 19. And when I plug in my x value, I'm replacing x, not y. So we have 3 minus 2y equals 19. So now that I have 3 minus 2y equals 19, where should I go from here?
Subtract 3 from both sides?
Yes, let's subtract 3 from both sides. I'm trying to get y by itself. So we're going to get rid of everything that is keeping that from happening. Minus 3. I'll bring everything down. Still have negative 2y equals 19 minus 3 is
16.
16. Good. And I've got just one more step.
Divide both sides by negative 2.
Yes. Divide both sides by negative 2. We should get y equals
Negative 8.
negative 8. So x is 3, y is -8. What is my coordinate?
3 -8.
Good. 3, -8. Any questions about level 1 elimination for number 3? Or we got that? Sometimes elimination, at least the level 1s, they can feel a little bit easier than the substitution. A little bit. All right, can I move this? Are we ready for number 4? Or not number 4, my bad. It would technically be, and this wasn't even number 3, this was number 5.
It's Monday.
Sorry, it's Monday, it is. Okay, so next we'll move and look at number 7. Good morning. Number 7. Tyler, we're using these 2 handouts up at the front. We're on number 7 right now. Okay, so I wrote on here that number 7 and number 9 are challenges. And that's because we haven't gone over these while I've been in person here with you. You did see a video on Thursday when I was gone, if you were here, covering these, but we're still going to kind of look at them together today. So I'm just going to copy down the problem first. We have -7x minus 12y equals -15. And then my second equation is 5x plus 3y equals -6. Okay. So I'm gonna write off to the side that this is elimination level 2. So you will probably right away notice that this problem, this system of equations, is different than number 5. Because in number 5, I was able to just add the equations together and we eliminate one variable by doing that right away. But with this problem, if I add my x's together, -7x plus 5x, I get -2x. I add my y's, -12y plus 3y, I get -9y. Neither of those cancel. So when we have problems like this, we have to remember that there are things we can do to equations, change them without really changing them. There's rules that we can follow. So to make x's eliminate or y's eliminate, we'll notice, for example, in number 5, the reason our y's canceled out is because both of them have the number 2 in front. One was negative, one was positive. So I'm looking to see, are there any numbers in front of my x's or my y's that look like I could get them to match? Now, right away, I'm looking at my y's. I'm thinking I have a -12y here, and I have a +3y. Is there something I can multiply my 3 to make it 12? There is. What if I multiply by 4? Yeah, okay, so let's take this whole equation times 4. Now, we have to do everything because if I, for example, add 4 to one side of my equation, I have to do it to the other side. If I multiply one thing by 4, I have to multiply everything by 4. So let's distribute this 4 to all 3 terms, and we'll rewrite our equation over to the side. So 4 times 5x, what does that give me?
20x.
20x. 4 times 3y,
12y.
that gives me 12y. Remember to bring over your plus signs and your minus signs if there are any. So I've got plus 12y. Bring over my equal sign, and now I have 4 times negative 6. What does that get me?
Negative 24.
Good, negative 24. Okay, so I just multiplied my bottom equation by 4. And now I'm just going to rewrite my top equation. I'm going to just bring it over so that these are still stacked up nicely. So I have negative 7x minus 12y equals negative 15. So I brought it over. And now, when I add my equations together, something's going to cancel.
The positive and negative 12.
Yes, my negative 12y plus 12y, that is 0y. So it cancels. So let's go kind of down the line. I'll bring down my equal sign. Negative 15 plus negative 24. Let's see, what does that give me?
31.
31?
Negative
Negative
39.
Yes. So I'm going to type it in. Negative 15 plus negative 24. Yes, negative 39. And we know our y's will
39.
cancel.
It's 39. 31.
And negative 7x plus 20x.
13x.
13x. Good. So now I have 13x equals negative 39. Process is the same for level 1 elimination from here. We're just going to solve for x. 5 by 13.
Negative.
Go ahead, Charles. What did you get for x?
Negative 3.
Negative 3. You know, I want to make sure everybody gets up to that point before we solve for y. Everybody gotten x equals negative 3. Bless you.
Thank you.
All right, so now that I have my x value, how can I solve for y?
Think, either equation
Mm-hmm.
and rewrite it, but plug in for the x.
Yes. Yes, 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 yes. All we have to do now is we can take either one of these equations, the original equations, and we're just going to rewrite it, but instead of putting x where it is, we're going to use the value we just found, negative 3. So I'm looking at these equations and I'm thinking my bottom one looks a little easier, smaller numbers. So I'm going to use my bottom equation.
Okay.
You can use the top one. You will get the same answer. But I'm going to use the bottom one. So I have 5 instead of x. What do I put instead of x?
3.
Good. Negative 3 plus 3y equals negative 6. And now that I've got it plugged in, where should I go from here?
Distribute.
Distribute 5 times -3 is
-15.
good. -15. Bring everything down. Plus 3y equals -6. Now we're trying to get y by itself, so what's a good next step?
Add 15.
Yes, add 15 to both sides. Let's get rid of that. Bring down 3y equals -6 plus 15. 9, right? Okay, 9. And one last step.
Divide both sides by 3.
Yes, divide both sides by 3. And we get y equals
3.
3. Good. Good. Okay, what's my coordinate?
-3.
3 and
Perfect. -3, +3. Very good. So the main difference in this problem, if we're comparing it to a level 1 elimination, only thing that's different here is that instead of being able to add them together right away, we had to multiply one of our equations to make a variable cancel. We had to multiply an equation to make it cancel. Now, there's never just one right way to do these higher level elimination problems. And I can show you a bit more of an example of that for the next one that we do, number 9. And we'll start talking even more in depth about that today after our break. Now, before we do go to number 9, does anyone still need to see this work, or are we ready?
Number 7.
Yeah, for number 7.
Okay, we do 7. Okay.
All right. Everybody ready? Anyone still need more time? Okay. All right, let me go ahead and flip my page. And this is the last one. After we work out this number 9, I will give you guys a little break, and then we'll come back and take some more notes today. So let's write that. Okay, and this was number 9. So this is another elimination problem. This one is what we would call level 3. I'll explain why. 8x minus 7y equals 18. And my next one is -6x minus 2y equals -28. This is where we have to multiply both equations. Okay. So whenever we have a problem like this, and I will tell you when you do take a quiz, I'll let you know in like the title whether it's a level 1, level 2, or level 3, so you don't spend too much time trying to figure out whether you need a multiplier or not. So you will know ahead of time. But with a level 3 equation, we need to multiply both problems because there is no number, if I'm looking at x's, there's no number I can multiply times -6 to give me 8. I can only do it with like a decimal. Hang on, I got somebody with a door. All right, so there's also no number that I can multiply times 8 to get 6. I can't make my x's match that way. So then I could look at my y's. There is no number that is not a decimal that I can multiply times -2, cancel out my 7. Same thing with 7. I can't multiply anything to turn it into a 2. So let's look at the first scenario. First option would be to cancel my x's. So if I can't make one match the other, let's make them both match. What I'm going to do is I'm going to look at the numbers attached to my x's. My first equation has an 8. My second equation has a -6. They already have different signs. So I am going to multiply both equations by the opposite number. Since this is 8 and this is -6, I'll multiply the top one by 6 and the bottom one by 8. We're just going to flip-flop the numbers.
You only do that if you can't multiply or
So-
can't, whatever you said.
Can't get it to cancel with just
You can't
multiplying
do
one.
anything with -6 to get 8.
Yes. So you can do it this way if there's no one equation that you can multiply to make it cancel, but you could also do this even if there is a way to make it cancel. So for like the last problem we did, number 7, you could do it this way too, and it'll work.
So you can always just multiply.
Yeah, you can always just multiply by the opposite numbers. It will work every single time. So the only thing you need to be really careful of is your signs. Because if first of all, let's see what happens when I multiply by 6 and 8. So let's distribute my top equation. What is 6 times 8x?
48.
48x. And then 6 times -7y.
-42y.
Good, -42y. And 6 times 18. 108. Okay, so then we'll do the same thing with the bottom equation. Now I have 8 times -6x.
-48.
Good, -48x. Now I'm going to pause us here for just a moment. Notice how our x's will cancel because I have a 48x that's positive and I have -48x. If I didn't have the right signs here, like if I had positive 48x and another positive 48x, they wouldn't cancel by adding. This is a situation where we would have to subtract, and we'll have to talk more about that later. But for now, these do cancel. It worked. So let's keep going. 8 times -2y.
-16y.
-16y equals 8 times -28.
-224.
-224. Okay, so I have distributed my 6 and my 8, and I've got 2 new equations that I can try to eliminate. So now we go back to the regular elimination steps. We're just going to add the equations together. So 108 plus -224. What does that give me?
-116.
Thank you. -116. Now I have -42y plus -16y.
-58y.
-58y. Okay, that's out of ink. -58y, and then my x's cancel. They're eliminated. So what do I do from here?
Divide divide both sides by negative 58.
Good. Divide both sides by negative 58. And we'll get y equals
-2.
negative 2. So we got our y.
Question.
Yes.
Shouldn't it be positive 2?
Yeah.
Yes, it should be.
Yeah.
Thank you. Y is positive 2. Not negative. Those two negatives cancel.
Oh, we did.
Good catch.
My negative.
Yes,
Everyone's
that would have
missing.
messed up our x whenever we plugged it back in. Thank you for noticing that. Y is positive 2. Or that. Okay. So now I have my y value. How do I find my x?
Can you still take either equation?
Yes.
Or plug in the
Either equation. Which one are you thinking?
part the 8x minus 7y equals 18.
All right, let's do that. We'll use the top equation. So I'll just copy that down. 8x minus 7y equals 18. And what variable am I replacing here? My y. So do not replace the x. Do not write 8 times 2. I don't know x yet. We're going to replace y. So I have 8x minus 7 times, instead of y, 2 equals 18. Okay, now where do I go from here?
Distribute.
Distribute. Negative 7 times 2 is negative 14. Good. Bring everything down. 8x minus 14 equals 18. Now what?
14 on both sides.
Good. Add 14 to both sides. Bring down 8x equals
32.
32. One last step.
Divide both sides by 8.
Good. Divide both sides by 8. And we should get x equals 4. And so what's our coordinate?
4, 2.
4, 2. Very good. Okay, so that was the first option. We decided to cancel our x's. This is good. I'm going to show you a second option. You don't have to do both options, but know that 2 options exist. So we decided to cancel our x's here, and that's what we did. The second option is that we could try to cancel our y's if you want. So I'm going to write that as option 2. We'll work that out as well. I'm just going to rewrite that problem from the beginning. 8x minus 7y equals 18. 6x minus 2y equals negative 28. Okay, so for the first problem, or for the first option to cancel the x's, we looked at the numbers that were attached to x, and we multiplied each equation by the opposite number. If I want to cancel my y's instead, I'm going to do the exact same thing, but we're going to have different numbers this time. So I'm looking at the numbers attached to my y's. I have negative 7 and negative 2. So what should I multiply my top equation by? We could do negative 2. Absolutely. What about my bottom equation?
This
You could do negative 7. You could do positive 7.
Oh, okay. I see what you're doing now, it's confused at first.
So you got it?
Yeah.
So you have a lot of options because here we had a positive 8x and a negative 6x. We still multiplied by 2 positive numbers. The reason I chose positive numbers was because we already have one of each sign. So that when I multiply positive 6 times positive 8, I get positive 48. When I multiply positive 8 times negative 6, I get negative 48. So the positive and the negative cancel and get rid of my x's. Now with my y's, I have 2 numbers that are negative. Negative 7 and negative 2. So what we could do is if I multiply my first equation by negative 2, that's going to change this to a positive number. The negatives will cancel. If I multiply my bottom equation by positive 7, like we said, this will stay negative. So then we'll have a positive and a negative. Now, if you don't do that, there's a lot of different ways that we could go. Let's for now go with the negative 2 and the positive 7 and see where we end up. So negative 2 times 8x. What does that give me?
Negative 16x.
Good. Negative 16x. Negative 2 times negative 7y.
14.
Good. Positive 14y. Negative 2 times positive 18.
Negative 36.
Negative 36. Good. Now I have positive 7 times negative 6x.
Negative 42x.
Good. Negative 42x. Positive 7 times negative 2y.
Negative 14.
Negative 14y. Do we see now why we wanted to multiply by a negative for the first equation and a positive for the second?
So
Now I have different signs. You could have done positive 2 and negative 7. It's just now you'll have a negative on top and a positive on bottom. There's lots of options. Lots of options. Okay, we'll do the rest of it. 7 times negative 28.
Negative 196.
Negative 196. Okay, so I multiply both equations. Now we can add them together. I know my y's cancel. I'll go ahead and cross those off. So, negative 36 plus negative 196.
negative 58x.
Mhm.
Oh, what'd you say? My bad.
Negative 36 plus negative 196.
Negative 232.
Negative 232. And you said negative 58x?
Yeah, I was
That's
looking at
correct.
the opposite side.
You're okay. You're okay. So we have negative 58x equals negative 232. And what would I do from here?
Divided by negative 2.
Divide by negative 58. Pay attention to the signs. We'll get x equals
Positive 4.
positive 4, which is what we got using the other method. So that's a really good sign. We got 4 last time. Now, if I'm doing it this way, how could I solve for y next?
Do like you did with picking either equation,
Yep.
plug in your 4's or x.
Absolutely. I can pick either equation again, plug it in, and find my y. I'll use the top equation again. We have 8x minus 7y equals 18. And this time we solved for x. So do not plug this into the y spot. This is x. So I will be writing 8 instead of x, 4. 8 times 4 minus 7y equals 18. Almost there, guys. Almost there.
This is like one of the longest
Yeah.
ones.
Yeah. And we are kind of solving it twice, so doing one.
Yeah.
Okay, so what do I do from here? We've got like 3 more steps.
Oh,
You distribute.
Distribute 8 times 4 is
32.
32.
X.
Do we need to write X? If I write X here, I'm right back where I started. We plugged in
We got
4 for X to get rid of it. I can't solve a problem with 2 variables. So we got rid of the X because we know what X is. So it's just 32. Bring everything down. Minus 7y equals 18. 2 more steps.
Subtract 32.
Yes, this is positive 32. There's no sign in front of it. So to get rid of a positive number, we subtract 32 from both sides. What comes down?
Negative 7y.
Good. Negative 7y equals
Negative 14.
negative 14. And one more step.
Divide by
Both
negative
sides by
7.
negative 7.
Good. Divide both sides by negative 7.
Positive 2.
Y equals positive 2, which is exactly what we got before. So we get the same coordinate, 4, 2. Same thing we got by canceling the x's first. We canceled the y's, we got the same answer. So that just goes to show there's more than one way to solve each problem. As long as you're following all the rules of math and solving equations, you're going to get it right. It doesn't matter which way you do it. Okay, it is 10:23. So it is time for you guys to take a little break. That was a long little do now. Good refresher for Monday morning. So let's see. We will come back at 10:40. That gives you 15 minutes to use the bathroom, get a drink, do anything that you need to do during this time. When we come back from break, we will look at the rest of that handout worksheet and we'll look at that graphing guide. So I'm just going to leave a little note up here. Be back at 10:40, take a break, do what you need to do, and I'll see you guys back in about 15 minutes.
Thank you.
Yeah, thank you. Okay.
Let's go.
So guys, we are back from our break and I'm going to just turn my page from our do now problems and we are going to start a little page of notes here. So I'll just title this as Algebra 2, Unit 1. And what we're going to do first is create kind of a guide displaying all 3 methods for solving systems of equations. So I'm just going to title this, I forgot what day it is, day 5. Day 5 notes. And again, it is Monday, October 13th. And we are coming to the end of Unit 1. Getting close to tomorrow, we'll have our practice quiz. Wednesday, we'll take our first quiz. So what we're going to do is create this guideline. And we're going to include everything that you'll see on that quiz. So systems of equations. I'm going to abbreviate that EQNS just to save some space. And the first method that we talked about when solving systems is substitution. And when we solve a system by substitution, usually we're looking at two equations where one is in slope-intercept form, the y equals mx plus b. And another equation is in standard form, ax plus by equals c. And when we use substitution, basically what happens is we take the standard equation, which I'm going to rewrite over here, ax plus b, but I'm not going to write y. And then we take the second half, the slope-intercept, x plus b, and we plug it in for y. So this is a general formula that we use, mx plus b. Solve using substitution. You may not realize it, but you've done this a million times already. We've done lots of problems where all we do is we take the second half of the y equals problem and we plug it in to the y of our standard equation, just like that. So, rough overview, this is what substitution is. And then the second method that we started talking about was elimination. Elimination is done when we have two standard form equations, so two equations with ax plus by equals c. And whenever we use elimination, there's a couple of different levels to elimination. This is where we're adding the equations together to get one of our variables to cancel. And we have level 1, where there is no multiplying. Two, where we multiply one equation. Finally, level 3, where we multiply both. Now, some people find level 2 to be a little bit tricky, figuring out which equation am I multiplying. You can use the level 3 method for any equation. I'm going to say, when in doubt, just multiply both always. Stop for a minute and let everybody catch up.
I was gonna ask you this thing.
Yes.
What was that I asked the other day where we had to multiply when I was like, something about you said we didn't have to multiply?
I'm trying to think. Multiply versus don't have to multiply.
Because it was something you went over and then I was like.
Read my screen and flip back through notes. Let me see. It had to have been from day 3, maybe. Is this? I think I know what you're talking about. I know exactly what you're talking about. Let me unfreeze this for a second. I promise I'll put this right back up. I remember it was right here because we added this little note where when we used elimination, we added the equations together and it canceled or eliminated the y's. And then we solved for x And then at step 3, we plug in x. We replace the x with 3, since I know that. And normally, after we plug something in, we have to distribute.
Yeah. Okay.
But this was a special case where x was by itself. So when we plug in 3 for x, there was no number outside of x to distribute or multiply. It was just 3.
So like, to ask you again, like,
Mm-hmm.
X would have been 1,
Yeah.
still would have been the same answer.
Yes. So technically, if I wanted to, I could go back to this note. It was 1x. I could say 1 times 3 instead of 1 times x. Still distributing the 1, but doesn't change that it's 3. Yeah, good question. Good observation. Good thing to bring up. Okay, I'll go back to my systems of equations that I'm having you write. So these are the 2 methods we've done a little bit. And the third option, this is the last option. This is graphing. And when you solve my graphing, we're typically looking at 2 equations, excuse me, where they're both starting with y equals, so both in slope-intercept form. So you'll see substitution is 1 of each. Elimination is both standard. Graphing is both slope-intercept. Now, to solve by graphing, we could graph by hand. Not going to be testing you over that, though. Second way is using a calculator, and that's what I will be testing you over. One extra little thing we can note for number 3, graphing, is that in our equation, this might ring a bell for those of you that may have just come from Algebra 1. In our equation that is y equals mx plus b, m is our slope, b is our y-intercept. That's all we're going to note about those. Everybody copy those down. Once you do have that note done, you're going to pull out this paper, the calculator handout. And if you do not already have a calculator at your table, please go get a yellow calculator. They are hanging up on the computer cart at the back of the room. There should be plenty of them in pockets over there, but you will need a graphing calculator, and we're going to use it to graph. Calculator can graph for us. So everybody get one of those calculators. Then we're going to look at how to solve by graphing. This usually ends up being everyone's favorite method because once you know which buttons to push, there's really no math involved. All you have to do is type in your numbers correctly.
Yeah.
Makes it real easy. So let's go ahead and take a look at this handout. And we're going to focus on graphing today a little more. If anybody needs to see that note again, just let me know. So on your calculator, you're going to have all these buttons that I have shown. on this paper, it says step 1, push the y equals button and type in both equations. So we're going to use the examples on this handout. And I'm going to teach you how to type these buttons. So first of all, make sure your calculator is turned on by pushing the on button at the bottom left-hand side. And then you are up at the top by the screen. You're going to push the button that says y equals. And you should get a screen that looks similar to this. And if there's anything typed in, you can use the arrow up and down keys to select those things and hit clear underneath the keys to clear it out. You want to have an empty screen like this. Give me a thumbs up when everybody's got this screen. Good. Okay. So we're going to type in both of these equations here. Now, I also kind of gave you a guide for which buttons we're going to be pushing. But for example, our first equation says negative x plus 2. So type in our negative. We've got that negative button down at the very bottom. We'll hit that. To type F on a calculator, you're looking for this button here that says XT, the theta symbol, N. And it's right here, kind of diagonally below the second button. So right here, XT theta N. When you click that, an X pops up on your screen. So I have negative X, then I'm going to type plus 2. And you should have this. Now, I accidentally typed it into the Y2 spot, but that's okay. It won't make a difference. Once I've got that, I'm going to use my arrows to move to the next empty slot. And we're going to type in the next equation. This one says 4x minus 3. So I'm going to type that. 4x, which is right here, minus 3. You should have these two typed into your y equals.
Oh, got a negative somebody.
Yes, it's a minus in front of your 3.
Wait. Okay.
So if you have a negative, you're only going to use the negative sign if it's in front of the x.
Okay.
If it's in front of the number at the end, you're using the minus sign. Okay, so we should have negative x plus 2 and 4x minus 3 typed into both spots, and that's step 1. So once you've got those typed in, we'll go to step 2, where we push the graph button to see the lines on a graph. And on your calculator, that's right under the screen to the far right-hand side right here. It says graph. I'll just push that button and
Hey,
look at that.
you can see
Yeah,
the drawing. It's important.
pretty cool. Our calculator does things.
Yeah.
Question,
Yes.
Ms. Taylor,
Wow.
those little boxes.
Those shouldn't be on your screen. That's my fault. I
Okay,
forget
I
why
was
they're
just
there.
wondering, because I was like, I don't have those. But
Let me see if I can figure out where those are coming from.
I don't
I don't know what I did to make those show up.
You have a special calculator.
I don't know. Yeah, those boxes shouldn't be on your screen. I don't know why they're on mine. I think I did something a while ago and never cleared it out, and I don't remember what I did.
started blinking on that one.
Yeah, but you should have 2 lines crossing each other like this.
Yeah.
Okay, so once you've got your 2 lines showing up on your calculator, now we're going to go to step 3. This is where we get the answer, so pay attention during this part. This is important. So to find the intersection is where the lines cross. That's going to be the solution. That's the coordinate that we've been finding in all the problems we've solved. You are going to press the second button, that's the blue button. And after you press second, you're going to push trace, which is right under the screen next to the graph button. So you push that. And then you should have a menu pop up that says calculate. 1 value, 2 0, 3 minimum, 4 maximum, 5 intersect. Once you're to this screen, you're going to select the fifth option. You could either use your arrow keys to arrow down to option 5 and hit enter, or you can just push number 5, the number button on your calculator. Once you push that, it's going to take you back to the graph and we'll be at step 4. So when the calculator reads, it's going to be really tiny print. It says first curve. Just going to push enter. Then it's going to ask second curve. Push enter again. Then it's going to say, you want me to take a guess? Press enter again. And your calculator has given you the intersection. Hard to see, but it says x equals 1, y equals 1.
Okay.
And guess what? That's your answer. No math needed. That's how you solve by graphing. Your calculator's kind of handy. So that's what step 5 is. Your calculator should display an x value and a y value for the intersection. And this is your solution. X is 1, y is 1. So your solution or your coordinate is 1, 1. And that's all there is to it.
So the problem is number 1. Minus negative x plus 2, 4x and negative 3.
4x minus
Minus
3. Yep.
Hmm.
So is your calculator doing something funny? Or is it working?
No, it's working.
Okay, good.
No,
Good,
I was
good.
just saying, I was just wondering what that's the problem.
Yes.
And then you take those step after 1, you take step 3, 2, 3, and 4, and number 5 is the answer.
Yes. So
Gotcha.
we can use this with some of the problems on our worksheet now.
Oh, you know.
So I'm going to have y'all look at number 11 on our worksheet. And we're going to use these steps to solve number 11. So we want to go back to the y equals screen. And before we start number 11, make sure that you clear out both y1 and y2.
Okay. So okay.
So you'll hit y equals. And then once you get to that screen, if there's still numbers and values typed in, you're just going to use the arrow keys to select and then hit clear to get rid of any of those. So for number 11, I have 2 equations. My first one says y equals 2/3 x minus 1. Yeah, that's not slow. So whenever we are typing in an equation, we don't have to type y equals because that's already typed for us. Y1 equals. So we're going to ignore the y equals and start right at the 2/3 x.
Did you type in 2 divided by 3?
Yes, you'll type it in just like a fraction, just like a division problem. So 2 divided by 3 is what you'll type for 2/3. And then your x minus 1.
Okay, then my x.
Yep. So 2 divided by 3x minus 1.
Wait.
Then we arrow down.
Hold on. Okay, 2 divided by 3. So what's x?
X is right under mode. It's
Okay,
the button
back to
that's got
that.
a bunch
Okay,
of stuff
okay.
on it.
Let me go back and flip that. Okay, 2 divided by 3. Go back to my x. Okay.
And then minus 1. Good. Okay, so now we're going to arrow key down and we're going to type the second equation. Now be very careful because there is a negative in front of 2/3 here. So we need to type negative 2 divided by 3 x plus 3.
Gotcha.
We'll get both of those typed in. And that's step 1. You just type in the equations. So once you have them typed in, we're going to go to step 2 again. That's hitting the graph button at the right-hand side, bottom of the screen. Hit graph. You'll be able to see your lines. graph, if you get an error message when you hit graph, it means something is not typed correctly. So if that happens, just let me know and I can look at your calculator. And once you've got your graph, we're going to go to step 3. We're going to hit second, trace, 5. Second, trace, and then I'm just going to click number 5. And it goes right into those questions for step 4. You're just going to push enter 3 times. First curve, enter. Second curve, enter. Guess, enter. There's your answer.
X equals 3,
Uh-huh.
Y equals 1.
X equals 3, Y equals 1.
And I have to remember that the X is linked.
So all we have to do for number 11 is write the coordinate. What's my coordinate?
X equals
X.
3,
Yes.
Y is 1.
So 3, 1. There you go. Not too bad. Yes.
I was gonna ask, do we still need to break down, like how we wrote the equations earlier with the other stuff when we're doing graph? So we got X and Y. We don't have to worry about that when we're just.
For graphing, when you're using a calculator, as long as you have just the answer written down, that's fine. Because these are kind of harder to check. I'll know that you did it wrong if you get the wrong numbers.
Right.
And then we can look back at it. But there's not really a lot of work to write down for these. So just the coordinates is fine with me. But if it makes you feel a little bit more certain, or maybe like, let's say you get to this part and you're forgetting, does X come first or Y come first? Well, first of all, you can remember that it shows you X first and then Y. But if you still forget and you just want to be doubly sure, you could always write X equals 3, Y equals 1. That way, if you do write it backwards, I can at least give you partial credit for having the correct values. Maybe you just wrote it backwards. Okay, so that's
Will this be on
number.
our text too?
Yes, the graphing. And you can use this little printout guide on your test. It counts as notes. Anything on paper is fair game. So this will be helpful.
So on the test, we're just giving you the coordinates.
Yep,
Okay.
that's it. Yes.
I was gonna ask you, can you show us how to, do we have to put the point on the graph part on the example?
You do not, but I do want to show you how to do it by hand in case any of you prefer it that way, because I will take both. So real quick, let's graph number 11 by hand. This is not something I'm testing you over. However, whenever you get to the graphing problems on your quiz, you'll get to choose if you want to do it by hand or not. So for number 11, first we're just going to graph the top equation, which is y equals 2/3 x minus 1. So I told you earlier, using y equals mx plus b, m is our slope, b is our y-intercept. So first we graph the y-intercept, and then we use slope. And I'm not going to go super in depth reminding you guys how to do this just because this is more of an Algebra 1 skill. And if you would like more practice, let me know. But again, I'm not testing you over this, so it's okay if you don't feel like a professional. So in my first equation, my y-intercept would be -1. So I would go to the y-axis and put a point on -1. So that's step 1. And then my slope is 2/3. And your slope tells you how far up do I move, how far over do I move. Rise over run. So if it's 2/3, I'm going to move up 2
Over
over 3. Up 1, 2, over 1, 2, 3. And here is the next point. And then you would want a ruler,
up 2 over 3.
and then you just connect those dots, and I've graphed one of my lines. Yes. So there is my first equation. Now, if I want to graph my second equation, I'll want to start over. What would my y-intercept be? Almost.
Oh, wait, 3. Sorry.
3, the number at the end. That's okay. So plus 3. So I'm going to put a point on 3 on the y-axis. And now this time, what's my slope?
Negative.
Yes, negative 2/3.
So you're going to go to the opposite.
Yes. So now instead of going up 2 over 3, I'm going down 2 over 3. So down 1, 2, over 1, 2, 3. And look, that's where it intersects. They share a point. So I'll just connect these dots. And this point where the lines cross would be my answer, which should be 3, 1. It is. So we did it right. Look at that. 3, 1.
Same illustration as the calculator.
Yes. It's doing what you're doing right here is what the calculator just did for you.
Yeah.
We do things a little bit more by hand usually in Algebra 1, and then in Algebra 2, we're learning more of the calculator skills. But it is good to look back and see where we started. So we have our answer, and this coordinate is 3, 1. Perfect. So this part is optional. This is more of a review than anything. Again, I'm not quizzing you over how to graph by hand on this. Okay, let's do a little more practice. Let's try number 12. And let's use our calculator to graph that. So we'll follow our steps again. Step 1, push y equals. Make sure both of your slots are clear. I'm going to type both equations in. So once we're ready and we're through this screen, what should I type for my first equation?
1 divided by 2x.
Good. 1 divided by 2x
Minus 2.
minus 2. Okay. And my second equation?
2x plus 1.
2x plus 1. Good. Once you've got them typed in, we'll go to our graph. Make sure they graphed correctly. That looks good. Okay, so that was step 2. We saw our lines on a graph. What do I do next?
Hit the second.
Yes, second, trace. Which option am I pushing?
5.
5. First curve, enter. Second curve, enter. Guess, enter. There's my answer. What's my coordinate?
Negative 3.
Yes, I got x is -2, y is -3, so my coordinate is -2, -3. And that is my answer for number 12. Good, good, good. Well, So what I would like for you guys to do is go to the back of this worksheet, number 13, 14, 15, and 16. I would love, and this shouldn't take too long, I would love for you guys to solve these using your graphing calculator. I'm going to give you guys about a little over 5 minutes, a little under 10 minutes. And I want you to find the coordinates for 13 through 16. And then we'll check our answers. 13 to 16. Just to give you guys some practice doing that on your own. So I'm going to pause our recording, let you guys try that. Feel free to help each other out if you notice your neighbor is struggling, or if you are struggling, don't be scared to ask for help. And then we'll look at these together in just a minute here. Okay, our time is up. So let's look and see how we did. Number 13. Oh, man. What y'all get for number 13?
1, 3.
1, 3? Did anybody get something different than 1, 3? Everybody got 1, 3. Okay, good. 1, 3 is the correct answer. Very, very nice. So, what about number 14?
3, 1.
3, 1. Did anyone get something different than 3, 1 for number 14? And if you didn't get to finish any of these that we're telling, make sure that you still type it in and get the same answer, because if you don't, I want to make sure that I can figure out what is the mistake that's happening. So I'd like for us to all leave confidently able to do this today. So number 14, we got 3, 1. How about number 15?
3, 1.
3, negative 1. Did anyone get something different?
I got 3. I got a positive 1.
You got 3, positive 1.
Unless I just didn't see the negative.
Well, let's see. Let's make sure. I'm going to go to my y equals, and I'm going to retype this whole equation in. And if you got something maybe different, I would love for you to do this with me. So I'm looking at my first equation. What am I going to type to enter that equation?
Negative.
Mm-hmm.
Negative 2 divided by 3.
Good. Negative 2 divided by 3. Then my x plus 1. So don't forget those negatives. Okay, good. So negative 2 divided by 3x plus 1. And just for safety, I'm going to type the other one as well. I've got 1 divided by 3x minus 2. I'll graph it. My lines are showing. There's 1. There's the other. And if I look really closely on this graph, if I wanted to, I could see if I counted over on the x-axis about 1, 2, 3 spaces over, about 1 space down on the y. So this looks like the right coordinate, 3, negative 1. But just to be safe, let's do our second trace. 5. Enter, enter, enter. And 3, negative 1. That is your answer. 3, negative 1. Perfect. Okay. How about number 16?
3, 4.
3, 4. Did anyone get something different than 3, 4? If you have not gotten number 16 yet, go ahead and type it in now. Make sure you get 3, 4. Because this is the correct answer. Make sure you're able to get that. Still typing. I want to make sure we all get number 16.
Was 13 and 14 more than 3 and 3 and 1?
Yes. 1, 3, 3, 1.
Okay. 3, negative 1.
Negative 1. 3, 4. Love 3s. Very nice. Okay. Very, very nice. Good, you guys. All right. So really that is the graphing method. Do not lose that handout I gave you today. This is a lifesaver. If you ever forget how to do it, you've got this guide that you can use as notes. Keep it in your folder. Keep it somewhere where you will not lose it. This is going to be very helpful later on. So I'm going to go ahead and put that to the side. And we're going to look at the other methods here. So graphing. It sounds like we've got a pretty good ability to solve by graphing, especially with the calculators and especially with the little cheat sheet. Substitution, we've spent the most time on. Elimination, what I have gathered is that level 1, you guys have got that. You've got level 1. Level 2 and 3, we have not spent as much time on. So this is kind of what I think some of our focus should be for the end of today, is just making sure we feel decent about elimination before we do a great big review tomorrow for the practice quiz. So here's what I'm going to have us do. I'm going to go back to the worksheet and let's look at number 8 together. And then number 10. So I'm going to flip my page. And I'm going to title this again. Algebra 2, Unit 1. And this is my page 2 of these notes today. We're going to use number 8 from the worksheet, number 8. And the problem for number 8 says negative 4x minus 2y equals negative 8. And then my second equation is 12x minus 6y equals 24. So this is technically a level 2 elimination problem. Technically, it's a level 2. Meaning we only have to multiply one equation. Now, if you have a hard time figuring out which equation is the best option to multiply, you can always use the level 3 method and just multiply both of them. Although you will definitely have bigger numbers. So what I would do is I would look at my x values and my y values, and I would think about, is there anything that I can multiply to make my x's match or my y's match? Let's look at x's first. I have negative 4x and I have positive 12x. If I want my x's to cancel out, which equation would it make more sense to multiply, the top one or the bottom one? The bottom to make 12 a bigger number?
Top.
Or the top?
Well, yeah, right, top.
Yeah, so the top equation has a smaller number. So if I multiply it by something, the goal would be to get it to have the same number as the bottom equation, right? So if I want my top number to go from negative 4 to negative 12, what would I need to do?
Distribute.
Distribute. What?
Take the negative 4x. Like you rewrite all that, but you take negative 4x times the 2y, the negative 2y equals negative 8, but you're multiplying it.
I see where you're going, but let's reel it back just for a minute because distributing is the correct next step, but we don't actually have anything to distribute yet. This is the hard part where we have to decide what number are we going to distribute. We're going to have to come up with a
Can you
number.
multiply by 3?
Yes.
Yes.
Multiply by 3. Because if I do 3 times negative 4, I get negative 12. Don't I? Oh, that could work. That could work. Now, if you're having a hard time coming up with the number that you need, if you're like, I really don't know what I can multiply by negative 4 to make negative 12, you can always start with, I say I need it to be 12. Oh, here, let me clear out of that. If I need it to be 12, I'll type that first. And then I could divide by the number I do have. I could say, let's divide by 4. When I hit enter, I'm going to get the number that I need to multiply by, 3.
So 4 divided by 12.
Yeah, so we're going to use 3 and distribute that into my top equation. And if we want to make a note of how we figured that out, here's what I'm going to write. Well, 12 divided by 4 equals 3. And 3 is the number we need to multiply by.
So basically, with the equations like we got,
Mm-hmm.
will it always have it where the bottom number we divide by the top number, or as your x's go?
We're going to take the number that we want, divide it by the number that we have, and that's going to give us the number we multiply by. So it won't always be the top or the bottom, just depending on how the equations are written. But we could label this and say, I need 12. Technically negative 4. So we're going to multiply by 3. Really, we want this to be negative 12 so that it cancels the positive 12. So that's why we're using positive 3, because we needed negative 12. So we divided by, we already had a negative 4. When we do that, we get a positive 3. That's what we're multiplying by. So we can use this to help us figure out what number to multiply. Now that I know I'm going to multiply by 3, how will that change this equation? What will I do next?
Take that 3 and distribute it.
Mm-hmm.
Your numbers down the equation.
Perfect. So what am I distributing first? What am I multiplying?
Negative 4.
Yeah, 3 times negative 4, which is
Negative 12.
negative 12x. And then,
Minus 6y.
good, minus 6y
Equals negative 24.
equals negative 24. Very good. We just multiply 3 times every term. And then we can just bring the other equation over. So it's 12x minus 6y equals positive 24, yes. Once I've brought that over, what am I going to do now? We are going to cancel some stuff out. How do we get stuff to cancel though? What process is happening? We're adding our equations together. Good. Okay, so my x's cancel. Negative 12 plus 12 is 0. Now I have negative 6y plus negative 6y.
Negative 12y.
Good. Negative 12y equals
0.
Yes, negative 24 plus 24 is 0. Now, when we end up with something like this, a lot of people like to freak out. Or they like to say, oh, my answer is 12. And that's not right. How do I get y by itself? Divide by negative 12. Keep following your steps. You can do 0 divided by something. That's okay. That cancels and we get y equals
0.
0. It equals 0. We got it. And then now that I have my y, how can I find my x?
Go back to what you plugged in.
Mm-hmm. Go back to my original equations. I can use either one. Which one y'all want to use? The top one? Okay, let's use the top one. I've got negative 4x minus 2y equals negative 8. And where am I plugging in this 0?
For the y.
For the y, where y is. Don't put it where x is. So I have negative 4x minus 2 times instead of y, 0, equals negative 8. And what happens next?
Distribute.
Distribute. Negative 2 times 0, what happens?
0.
It's 0. So really it cancels. Because I don't need to write negative 4x minus 0. That's just negative 4x. When you multiply by 0, you cancel it. So I'll bring down negative 4x equals negative 8.
And divide both sides by negative.
And divide both sides by negative 4. Good. And we get x equals 2.
Bless you.
Bless you. Here we go. And what's our coordinate?
2 and 0.
2, 0. Nice. Nice. So there is some level 2 elimination where we just multiply one equation. Now we've got about 15 minutes left. And I am thinking what I would like for y'all to do for your exit ticket today. I think you guys can do number 10. I really do. The level 3 elimination, number 10, that's where we're multiplying both equations. It will be just like number 9. Now, don't be scared. It's Monday. You have until Friday to finish this. And let's say you don't get it right today. To make corrections. And ask me for help if you need help. But your exit ticket, I'm going to go ahead and write a note here. And I can show that note page again if anybody needs it. Your exit ticket is number 10 on this worksheet. And I will make copies of this exit ticket if anybody wants it. I will also accept your worksheet as the exit ticket. Number 10 on that worksheet is, first equation is 8x minus 3y equals 22. Second equation is negative 6x minus 8y equals 4. So remember, this is a level 3 elimination, meaning look at the numbers that are on your x's or your y's, multiply by the opposite number to try to get them to cancel, okay? That's kind of the biggest hint I can give you. Like this here, the slide. Oh. This is due Friday, October 17th. Got the rest of the week to finish. So, that's our lesson today. I'm going to end our video and I will run some copies of this if any of you want a separate copy. Those will be coming here in just a minute. But if you finish this, or if you got places to be, you are free to go. Just know that this is due on Friday.